Today's show is sponsored by Panoptica. Panoptica simplifies container deployment, monitoring, and security, protecting the entire application stack from build to runtime. Scalable across clusters and multi-cloud environments, Panoptica secures containers, serverless APIs, and Kubernetes with a unified view, reducing operational complexity and promoting collaboration by integrating with commonly used developer, SRE, and SecOps tools. Panoptica ensures compliance with regulatory mandates and CIS benchmarks for best practice conformity. Privacy teams can monitor API traffic and identify sensitive data while identifying open source components vulnerable to attacks that require patching. Proactively addressing security issues with Panoptica allows businesses to focus on mitigating critical risks and protecting their interest. Learn more about Panoptica today at panoptica.app. That's panoptica.app.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And it is Aaron for Cloud News, but I'm going to ask a favor of everyone out there. Going to do Cloud News slightly different this week. Part of it is just simply because I'm out of time. I only have a couple minutes to record this, and I got to go into the office to do executive briefings and customer briefings for the rest of the day. But I wanted to make sure we got this covered. So instead of Cloud News, what I've done in the past is there's a bunch of links, and then I kind of pick the top three, and I go into them in detail. I'm going to do speed round this week. Of course, all the links are in the show notes, but I'm going to actually go through the entire list very quickly this week, but I'm not going to pick a top three or go into details. So if you have feedback on, do you like one, do you like the other, let us know, please, because this is an experiment this week. With that, here we go. Here's the list. Splunk, 2023 State of Observability Report. They just pushed that out. Looks good at first glance. Definitely go check that out. Google published an executive guide to generative AI. I, again, really looked at that one very quickly, really liked it. Stable Audio launches generative AI for music and audio. I couldn't get it to work because the website was just cratered, but hey, it's out there. Octo AI, Octo ML, recent guest, and they just released accelerated versions of Llama 7B, 13B, and 70B with really no sacrifice to accuracy on that one. Here in the United States, the White House did an AI safety accord that is definitely worth looking into. And kind of in relation to that, there's another article on why regulating AI is so difficult. The Google Cloud Next replays are available, and especially you can kind of sort it by sections of do you want infrastructure, do you want AI? So those are out there. I always say I'm going to go back through them, and then I never do, but hey, maybe this year I will. Then there is a beginner's guide to event-driven architecture that at first glance looked like a really good article, very good introductory article about everything. And then lastly, and maybe this is going to be one of the bigger news pieces coming up soon, the rumors are Google is nearing release of Gemini. If you're not familiar with Gemini, Gemini is the next version of Bard, if you will, right? It's the GPT-4 competitor. So apparently it's already in closed beta and will be in open beta before too much longer. So if any of that is of interest, of course, go take a look at the notes. But I'm going to wrap up Cloud News for this week. And coming up right after the break, we're going to be talking to Alex Ratner, the CEO and founder of Snorkel AI.
Are you looking to stay ahead of the curve in the latest trends in enterprise tech? Look no further than the Breaking Analysis podcast with Dave Vellante. This data-driven program dives into the most important topics facing the enterprise tech industry today. With a data-first approach that leverages ETR's renowned surveys of IT decision-makers and insight from the CUBE community, Breaking Analysis delivers in-depth research on the most important topics facing technologists and IT buyers. Whether you're a business leader, an IT professional, investor, or just an avid follower of the industry, this podcast is a must-listen. Just search Breaking Analysis Podcast wherever you get your podcast and tune in today to stay ahead of the game in enterprise tech. And we're back. And Aaron, believe it or not, we're going to talk about yet another aspect of AI as you and I are going through both a learning journey for ourselves, also a learning journey for the community. But today we're going to dive into a little more of this. Give me a sense of of where you are in your journey so far? Because I know you're doing this not only quite a bit with the show, but you're mixing this in with your day job.
Yeah. So it's been interesting. For the day job, I do cloud native technologies, and then of course this kind of fits very well into all of that. So I've been handed AI marketing as well for the day job, and that has caused me to do a lot of research on this and sipping from the fire hose, which has been fantastic. And the overlap here has been really good, and I know we won't say we've pivoted because we haven't, but we've done more shows recently on AI, and we've done them historically over the years here and there. And our guest is actually a returning guest, which for the AI community, that means, our guest is OG for us. And so with that, I'd like to introduce Alex Ratner, CEO and founder at Snorkel AI. So I guess I should say welcome back to the show, Alex. How are you?
Thanks so much for having me back. I'm great. I really appreciate the time. Absolutely. And it's hilarious. Yeah, it's I never thought of myself as OG AI, over the last decade, given how old AI is. But I guess in today's environment, I guess that counts, right?
Yeah.
It's I was not doing crypto 6 months ago. I was actually still doing AI.
That's right. Anybody who was doing AI before LLMs and ChatGPT came along is OG at this point. So we last spoke about 2 years ago. So a lot has changed. So we thought it'd be a great time to get you back on and talk about some updates. So for those that aren't familiar, give everyone just a quick background, please.
Awesome. Well, quick personal background. Yeah, I'm currently one of the co-founders and CEO at Snorkel AI. We spun out of the Stanford AI Lab, where one of my co-founders is a professor there back in 2019. And then back at Stanford had also led what we call the Snorkel Project. And I'm also on faculty at the University of Washington. So currently affiliate, not teaching right now, focused on the company, but still get to work with some great students there. And the big umbrella around all of that over the last 9.5 years, Stanford, UW, and Snorkel is what we call data-centric AI development. So kind of concentric circles, I'll start with the biggest one. Over the last 10-ish years, our focus has been everything around how you develop, label, sample, filter, clean, curate the data that goes into AI models. The simple metaphor is, AI, or really we mean machine learning, which is a subset of AI. It all relies on data. That's the fuel. It's often called training data because it's kind of what the models learn from. If you want to teach a model to tag a certain type of bird in an image, you have to show it a lot of images with that kind of a bird labeled, and or also lots of images of birds and other creatures unlabeled, so it can learn about those concepts. So all of this data, this is what shapes how all these models perform, including the large language, or we call them foundation models. And a lot of the traditional workflow, certainly when we started back in 2014, was very much model and algorithm centric. It's still how we teach AI and ML in classes, how we structure it in large enterprises. Honestly, it's very much around data science and AI as a profession where you build models, you tweak models, you tweak algorithms and tune them. You watch loss curves, and that's getting a lot more standardized, a lot more automated, and a lot more opaque and black box. To put it intuitively, use a model like a ChatGPT or a modern foundation model. You can't just fix an error mode by tweaking one of the a couple 100 billion parameters. So where does the actual AI development interface go to? Our exploration, and now it's less exploratory. Our argument is that it really shifts to the data, the labeling, the curating, the filtering of that data, whether you feed it into a prompt or you use it for tuning or pre-training. That's kind of where you actually get to edit and program the model these days. So that's what we mean by this concept of data-centric AI development. And then within that, the mission, first at Stanford and UW, and now at the company, is to make that data-centric development, all the labeling, but also sampling, filtering, cleaning, curating of the data that goes into all stages of teaching and training these models, customizing them for specific enterprise settings and use cases. Our goal is to make that a first-class workflow, because a lot of the traditional AI platforms and curricula view this as kind of janitorial work, whereas our whole point is it's kind of becoming the key thing. So A, make that first class, and B, make it more programmatic. That's not automatic. We're not saying this is just going to auto-magically go away. We're trying to make it look more like software development. So if you want to label or sample data to curate a better training set in SnorkelFlow, our platform, you write a labeling function or a sampling function, which is a little piece of code that expresses some domain knowledge of how to do that labeling or sampling or filtering. And we have no code interfaces, natural language, or actual SDKs for developers. But the key idea is make all this data development that's increasingly the interface to AI, to building it, maintaining it, understanding it, make it look more like software development versus, sending a bunch of images out or documents to some people somewhere to go click, click, click for, a couple of weeks or months or longer. Just to kind of tie that off, we do this at the company now with a lot of enterprises, especially ones that have very business critical use cases that need to be very accurate. So they're not little human in the loop demos, which we're seeing a lot of these days and are quite impressive. They're applications that need to get shipped to production, and most of what these kinds of use cases required, and they're over very kind of unique, complex, bespoke data, something in the bowels of a bank or a hospital system or a government agency. In most of these settings, you actually need to tune these large language or foundation models to get them to work. And we help do that tuning via all the data development. So we work with 7 of the top 10 US banks, government agencies, healthcare, all these settings where the out of the box, large language or foundation model isn't quite going to cut it, and you need to tune it. And the key to that tuning and development is data development. So I'll pause there. That was a long spiel, but hopefully that kind of situates us.
No, that was fantastic.
No,
that was
super
fantastic.
helpful. Super helpful. I want to clarify something and apologize if this is a super newbie question. So you mentioned that we're seeing more and more of these models are becoming kind of standardized. We're now calling them foundational models, or at least the rest of the world is hearing of this concept of foundational models. Does that essentially mean that we're fairly close to being everybody's going to kind of be working with these 10 or a dozen or 24 or however many kind of foundational models, be it a Hugging Face or a llama or something else. And those become sort of everybody's kind of working from the same starting point from a palette. And then, as you're saying, all the value, all the creativity, all the domain specific stuff sort of then lives around other parts of the overall workflow around the edges of that? Or am I misreading that?
No, I think that's a very fair read. I mean, at a high level, that is what I'm saying. I think there's nuance in that. And I'll double back to that. But at a high level, I guess I'll say it in a more, pardon me, black and white way than I mean necessarily, just to make it interesting podcast fodder. But the one heuristic kind of way I think about it is, you've got the inputs to kind of training and developing models. You've got the outputs of where you plug in the model. I think everything in between is getting quite commoditized from a user's perspective. The inputs, the data, and the knowledge of how to kind of label and curate and select it, that is very specific to your domain, your enterprise, your setting, your use case. The outputs, what workflow do you plug it into? What user interface? What business process? What deployment method? A lot of that is very, again, domain, use case, company specific. So I think you've got a lot of differentiated, value on those ends. But the actual models and the algorithms, they're really becoming rapidly standardized. It's not to say there isn't innovation there. Like a lot of the work that my co-founder Chris Ray over at Stanford is putting out is actually on new model architectures, algorithms, et cetera. But it gets to the open source so quickly. And if you look at the Llama paper, Llama 2 paper, the GPT-4 leak details, they're engineering marvels, and they deserve immense credit for that. But there aren't fundamentally new tricks on the model or algorithm side. Actually, the thing that they're most, hush hush about is the data, and how they spend all this time and money curating it. And one example there I'll give from the academic side. So a couple of folks over at UW, one of the students I co-advise, a bunch of other people, Google and Apple and Stability Online as a big consortium, put out this thing. You can check it out on the internet. It's called Datacom, kind of set up as a competition. But the quick TLDR was that we held everything fixed around all the code for training a model. In this case, it was a multimodal foundation model. If you've heard of CLIP or DALI, it was basically that model architecture. All the training code, all the model architecture decisions, everything was held fixed. And we just had people play around with how you sample and filter the data. This was just, for those that are in the weeds a bit more, this was just pre-training, by the way. So you didn't even get into labeling the data for a specific task. It was just pre-training. And that data curation yielded a new state of the art that was, that beat OpenAI and everything else at compute parity. So it's not to say that the model, the algorithm, et cetera, doesn't matter, but it's really flattening. And what you put into the model is the key. It's kind of like if you use a cooking metaphor, we're getting to a point in this space where everyone's kind of using the same recipe. So it's really coming down to the ingredients. That's kind of the state that we're in.
Yeah, no,
that makes perfect sense.
Yeah, no, and it's super helpful because as we've learned from every other stage of technology, like at some point you need certain things to stop being so in flux in order for, more things to sort of be able to advance. So, that was helpful.
Yeah.
Yep. Alex, let me ask you kind of to elaborate a little bit more on when we're talking about fine tuning model specifically. Like, let's say a company out there, they just take a, off the shelf model, a Llama 2, for instance, right? And when it comes to making it their own and building a model that is specific to an organization today, do you have to, is it fine tuning it to the needs with user specific data? Is it around the data labeling? Like, where does the specificity come in, if you will? And how do you recommend organizations kind of think about that when it comes to taking something and like call it an engine for lack of better details, right? Like an off-the-shelf model it's simply more than a template. How do you fine tune it for your organization? How do you get started?
It's a great question. So the quick answer at a high level I'd give is just two main ingredients. One is evaluation targets, and the second is data labeling and curation. So, you've got to have a clear sense of what are you fine tuning it for? That might be a set of benchmarks specific to your organization. What kind of things do I want this chatbot to answer well? It might be a very precise target. Like, I need to classify this type of fraud, and here's a way to, measure the accuracy on a validation set. But you got to have that target before you can actually tune and customize the model. And that may sound obvious, but it's very underappreciated and under kind of cooked in the space right now. And the second thing is just all comes down to the data. There's lots of innovation on the algorithmic side of and even model side of how do you do the fine tuning, but it's kind of for an average use case, it's all out there in the open. It's all pretty standardized. So it really just does come down to how you curate the data for that specific fine tuning objective. Now, I'll note, taking a step back from fine tuning, you kind of hear, and moving forward, you'll hear about kind of three major tools that people talk about for customizing models. Number one is prompting or prompt engineering. Number two is retrieval augmented generation or RAG. And number three is fine tuning, which is some kind of data labeling, data curation, and fine tuning the model. Now, people love false dichotomies at an early kind of like, at a tumultuous time in the space like this, but they're really just complementary tools. And we're actually doing a lot of building, not just talking, but also building around how we see them all fitting together. So simple, intuitive metaphor. Think of prompt engine, like think about a med student. Think about an off-the-shelf model as kind of like an undergrad or a med student. And let's say you're trying to teach them to diagnose a patient. Prompting is kind of just like, literally just like giving them the instructions. Like maybe if I give the med student slightly clearer instructions and guidelines for what they need to do in the room with the patient, they'll do better. And that's a good way to kind of get started. But, to use that metaphor, when you get to really high performance, bar domain specific settings, that usually taps out. So it's a good first mile tool. It's a good place to start, but it usually gets quite difficult. Fine tuning is basically actually just kind of teaching the med student, let's say, to make better decisions in this specialty area of interest. And RAG is the equivalent of like looking up the patient's chart and bringing in external information that's needed to make the decision. So they overlap a little bit, but they're very complementary tools. Is this a kind of simple, easy problem that I just need to kind of just give a little bit of more of a precise instruction to? Then, well, let me just start with prompting. Is it something where I really need to get higher accuracy and it's really about teaching the model to make better decisions in this domain? That's fine tuning. And is it about something that like the model just doesn't have access to this external information in my database, or some documents somewhere that it's never seen before? Well, then I need to get that into the model, and that would be what people are referring to now as just RAG. Does that make sense? And it's just
yeah. But let me ask maybe a follow on to that too, because I mean, and again, as folks are getting introduced to all of this, and a lot of our listeners are newer to all of this, there's also this perception that the more parameters are better, right? GPT-4 is better than GPT-3 because it has, so many more parameters. But at the same time, our organizations, if we're looking at truly purpose-built things, maybe bigger isn't always better, because maybe it's harder to train it or fine tune it or even run it. And so do you think we're going to also run into more like slim down purpose built ones? Like, for instance, I know Llama, the Meta folks like Code Llama, which is a version of Llama, but specifically for writing code, right? Do you see that happening and folks going more with like, hey, taking maybe an off the shelf model, but then you training it down, if you will?
Oh, I mean, yes to everything you said. I think the key phrase is yeah. Do I get out of answering the question now if I just say yes? yes to everything.
Fair.
No, I won't be that lazy, even though it's a Friday. The key phrase I think there is purpose built. It's I think one of the key axes in making these decisions as an organization or just thinking about the space is kind of general to specific. So let's take a step back first before that, though, and just say, like, there's lots of nuance on how many actual parameters you need relative to the data you have, relative to the task specificity, like we'll get into. Scale does matter, though. And the lesson that, you called me an OG AI person. I still think of myself as, as new to AI relative to the true OGs, who have been, working on this for multiple decades. I mean, the term large language model, for the record, was, I think, coined in a 2007 paper from Google. And before that, there were language models back when we just called it statistics back in the 90s. And so, but even for those of us who've been around for, a decade plus, or even shorter, I'll call it like we basically, almost all of us, other than maybe OpenAI and a couple others, really underestimated the power of scaling kind of these basic self-supervised approaches. So scale matters. That's been a resounding lesson of the last, year or two. But then the nuance is, it really depends on what you're trying to do with it. If you want a really generalist model that can really just be like an assistant or a co-pilot for everything and can do everything from, answering questions about the Klingon homeworld to like making poetry about coding interviews. I don't know. That's my random, like, internet summary of the day. Then yeah, I do think these massive models are going to have a leg up. I think it's going to be very winner takes all because of the feedback loops that are quite powerful in terms of getting more data and feedback. I think scale will continue to have an effect, and I think open source will really put up a fight. But I do think some of the the OpenAIs of the world, and I do think it's kind of winner takes all, will have a leg up just because of the sheer compute and data scale that they're and model scale that they're throwing at it. But the thing is that most certainly most enterprises, that's the space that we operate in, but So I'll just stick with that because that's the domain I know better. I don't want to pretend I know as much about consumer uses of LLMs or creative uses, but most enterprise use cases, you care about doing, and I mean enterprise, not just for profit, but nonprofit as well. A nonprofit hospital system, et cetera. You care about doing a bunch of very specialized things very accurately and robustly, and often cheaply and quickly. And they're smaller specialized models that are often kind of derived, and you said kind of trained down, which is a thing. It's called distillation. We had one of the students I co-advised a paper with Google recently on this. It's an old technique actually, and a very powerful and important one in today's space. So anyway, summarize all that. I think what you're going to see is these big, massive generalist models are going to continue to have a place. Maybe it's more consumer or certain use cases where you need tons of generality. But a lot of the actual deployed AI in the enterprise is going to be these smaller models that are either kind of fine-tuned variants of small to mid-sized models, or they're kind of distilled down from the larger models. And they're just really good and really dependable and really efficient at one thing, like monitoring customer call center transcripts or tagging certain things in aerial imagery or looking for certain types of medical issues. So I think that's the kind of the general to specialist spectrum is where we're going to see this play out. Does that make sense?
Yep. And one more follow up on that. If I take it even one step further, and we go down this purpose built, I like your idea of a model that is trained on fraud detection, right? For an enterprise. And to take that even one step further, I could see it's used at, I don't know, like a bank, because a bank would have a whole bunch of branch offices, right? A more old school bank than, say, an online only bank. And so would it be also to the idea of where you train it or where you retrain it or fine tune it or where inferencing or running actually happens could be very different scenarios and very different resources? And then to make that question even harder, how does data and privacy concerns fold into all of that?
Can you just cover everything about AI
just
and we'll
give us everything all at once? It'd be helpful.
Yeah, just in the last one, I was 2 or 3 minutes we have. Yeah, sure, no problem. No, I mean, I'm not going to cover all that. I'm not going to be able to. I admit defeat. Let me just come clean at the beginning of the answer. But I do think, just to pick on one thing that ties to that general to specialist thing, I think you're going to see these kind of family trees, almost trees of branches and forks off of the big models. That's why one of the reasons why we like the term foundation model at Stanford and at the company at Snorkel. They're bases that we think all of AI is going to be built on top of, not just language, not just generative, all of AI, but you got to do some building and development on top. And a lot of that, I think, is going to be looking like kind of taking these big models. Maybe you have the central enterprise model that itself was kind of, forked off of a big, open or closed source model. And then you just kind of have these branches. You already see this happening in the open source with these and closed source of these model kind of family trees. I think you'll see that at every organization over time, where you have, to varying degrees, the kind of big central model that is kind of tuned to your general domain. And then you have these kind of specialist models that are both more specialized to your example, the branch and the specific type of fraud that this type of system is looking for, say. And also in doing that, you actually have a kind of federated setup that can protect data privacy a little bit more, keep certain data silos a bit more localized. And also lead to kind of more efficient performance at the edge. So I think it doesn't touch on everything, but I think that kind of that design pattern is what we're going to see more of, and it does answer a bunch of those questions just kind of naturally.
Perfect.
Yeah, I want to ask you one last question. I'll make it quick because, like we all said, it's Friday, and we got other things we'd like to do. Especially as you work in the enterprise, how have you seen? Because nowadays, especially with ChatGPT, even though that's not necessarily an enterprise app, people are now like, oh, AI has a user interface. How are you seeing? We've had data scientists for a while sort of be the programmers of AI. We're now having people building, essentially front end applications that are interacting with these models. What are you seeing in the enterprise? Are they able to take today's standard Java and Python developers and get them plugged into this, or is there still sort of a specialized set of developers that are building the sort of user-facing part of the application?
So I think a lot of it depends on the use case. I think, big picture, these tools, again, we like the term foundation model because it's like, or I guess it's summed up in that. I think it's a great democratizer, especially for kind of use cases where it's all about the first mile, and that's good enough. And then when you get to the last mile, kind of the building the house on top, you still need experts, you still need data scientists. And within that, I do think the data scientist skill set and toolkit is going to have to shift more from models and algorithms to data and data engineering and development. So I think there's a big shift in the toolkit, but there's still a need for those specialists. But again, I think it depends. So there's going to be some use cases where, you're building a creative assist tool where the endpoint is something that is going to be very human in the loop and very assistive. That I think you're going to see a lot more just kind of building, with folks who are not expert data scientists, because it's very collaborative, and the bar that you have to hit is lower, right? Because it's going to be a collaborative tool, so it doesn't need to be perfect. And then on the other end of the spectrum, you have a fraud detector in an enterprise that might have regulatory and massive financial consequences, needs to be super accurate. And there, you're absolutely going to need data scientists and others working together to really tune and develop the model. So I think you're going to see, yes, the floor will drop in an amazing and exciting way for how much data science skill do you need to be able to start playing around with these things, to start being able to build something with them. That's super exciting. And it's going to be an amazing democratizing force. It's going to bring more people in the loop that have the domain knowledge to actually get AI cross-line, which is awesome. And then, some use cases, that's enough because it's easier, it's simpler, it's, there's less, there's more error tolerance because it's human in the loop, let's say.
Yeah.
But then when you actually have those enterprise deployments that need to be super accurate, super performant, which is a lot of enterprise AI, that's especially when you weight it by value, by business value or consequence of failure, that's where you're absolutely still going to see data scientists, but their skill set, their focus is going to have to shift. That's kind of a summary of our high level view. And we're very excited to be supporting that in a bunch of big enterprises that we work with.
Great.
Makes sense. Well, listen, Aaron, we have tapped Alex for more than enough of his AI knowledge for one afternoon. Thank you so much, Alex. We really appreciate it. Aaron, one thing we forgot to do, we've been working with folks on the West Coast. We've been lucky to work with some folks from Stanford here and there over the years. We forgot to welcome them to the ACC. They're now basically in our backyard. We're basically tailgating buddies. So welcome to all of those Stanford alums who've been on the show, and welcome to the ACC.
Yeah. So much.
Thank you, Ed.
Go ahead.
No, thank you. And thank you for having me on the podcast again. It was an awesome discussion.
Absolutely. So I'll go ahead and close this out. Alex, first of all, thank you for your time. And on behalf of Brian and myself, thank you everyone for listening. We certainly appreciate everyone's time out there as well. And of course, if you enjoy the show, leave us a review, tell a friend, and certainly we want feedback. Please give us feedback. And if you have any suggestions for guests as well, we'd love to hear that. So with that, I'm going to close it out for this week, and we will talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.